Okay, so what we have here, question 10, we have a sample of n equals 266, and there's students taking an online course. They're asked to describe number 1 through 7, and the average score was a 5.65, which is X bar. And then we have a standard deviation of S equals 0.95. They never tell us what the population standard deviation is going to be. So we have to assume this is from the sample. And we're going to construct a confidence level 0.99 for the t-distribution. Now, come over here to class calc. And right here we have 266 minus 1 as degrees of freedom. Here's n equals 266, subtract 1. And we find the inverse CDF, which gives us z-score for alpha over 2. And because we're doing a 99% confidence level, 1 minus 0.99 is 0.01, and we divide that by 2, we get 0.005. That's why we have our confidence level here, divided by 2. Now, we have 2.5945. So we're going to do 2.9545 as our critical value. And we got that from the t-distribution. Now we multiply that by our standard deviation, 0.95 times 0.95. We get 2.806, but we need to divide this by square root of 266, which is our sample number, or sample size, sorry. We get 0.172. This is our margin of error, and it's asking us to construct the confidence interval. So we take our average 5.65 and we subtract this number from it. Let me just get rid of all of this here. Okay, so we're going to subtract times -1, and we add it to our sample average, 5.65. 5.65. And we get the bottom 5.47, 5.48. It says to round to 1 decimal, so I got 5.5. And then we have to take this and multiply it by -1, and we add it to 2 times our average, which was 5.65. And we get our 5.8. So 5.5 to 5.8. Now, it's asking if the mean score for students being 5.58 was the actual population mean. And it's asking if this confidence interval contradicts the claim. And because 5.58 is between 5.5 and 5.8, it does not contradict the belief.